touch anything. You only pay attention and that's it. Do you see the whiteboard?
Yes.
Cool. Now, in the first chapter, in the second chapter, this is the second chapter. We study meeting with the Jorge. Reading test, yes, yes, yes. No, but I resent. Don't worry for this. The students that have not the test, you receive with the next email I send today. Okay, so now we focus in quadratic functions and of course applications. So we are super familiar with the quadratic function because quadratic function is shell, I think, on Alex. Okay, guys, any question that you have, you email me, okay? After the class. I cannot sit. Now is the moment to explain mathematics, okay? Then the next mathematics. That some students help me to explain, but no, you relax. When the class is over, I resend the test of it, okay? Okay, entonces you are familiar with the quadratic function. Quadratic function is a function x squared. Que you know very, very well, it's a parabola. It's a classical parabola, like that. However, we study in detail the family of the quadratic function. So there are two different ways to express the quadratic function. This way you are a little bit familiar. Because in your moment, we are solving a quadratic equation, and the quadratic equation is solving similar to this. You put equal to 0. This is because I want to find the x-intercept. But now, this is I want to call the name of this is standard. This is a standard form. However, we have another way to express the same idea, the same function, is like that. A parenthesis x minus h squared plus k. And the name of this second way is called a vertex. And you see in detail now what is the reason that the name is vertex and other is standard. So the most important thing in this today is that we are doing the graphic of the parabola. Of course, this graphic have transformation because when you multiply by a, addition bx plus c, this is transformation. What kind? I don't care too much this, but it's transformation. So we have different parabola, and the most important point in the parabola is the vertex. What is the vertex? The vertex point is the point in which the turning point of the parabola. This is the vertex. Okay? And this specific elementary example is 0,0, no? But not always is 0,0. In general, the component of the vertex is h, k. Be familiar that h is the x component and a k is the y component of the vertex. And this is extremely important. The vertex is see, you are doing the graph and you don't emphasize the vertex, you are doing nothing. The vertex is a super important point when you do the graph. But in the vertex form, wow, it's easy because you take a look only, the vertex is h, k. Look in this number. Look at this number, you look at this number, h, and look at this number, k, and this is bivertex. And this way, I don't know. Let me try to explain that. But okay, let me finish this. So the most important, vertex. Here, I don't know how you find the vertex. I explain soon. Okay. Now, what is the other important? The other important is In what direction open the parabola? So this is the first thing. The second is in what direction open this parabola. Because we have two possibilities, ¿no? Es a vertical parabola. Entonces open up o open down. Entonces, what is the parameter que control in what direction open? Oh, it's A. A, by the way, this A is exactly the same of this A. They are coincidence of the parameter. A is A in any way. Si A is positive, the parabola open up. Si A is negative, the parabola open down. Okay? This is super important. Determine who is A. You see example after. I explain now theoretical part. Okay, number three, important thing you need to determine is symmetry. Actually, it's axis of symmetry. Let me erase this. Axis of symmetry. Axis of symmetry. What is that? It's easy. It's a vertical line always. Vertical line can split the parabola in two equal parts. Suppose this is our parabola, and this is perfect axis of symmetry because that part of the parabola is identical to that part of the parabola. And by the way, the equation of the axis of symmetry is x equals something because it's a vertical line, and x equals h because h represents the first component for the vertex. This is the vertex. Look at that. H, k. Axial symmetry. Split the parabola into parts. This is very, very important because maybe you have different point here. And using the symmetry, you can determine the image in the other branch of the parabola, and the axial symmetry behave like a mirror. Yeah. Not too much. After you interchange, I know that you have a chat. Stop benches, please. And number four, is extremely important. Number four is the y-intercept and x-intercept. I put together. What is the formula? What is the formula for finding the y-intercept? I'm using function notation, evaluate the function as 0. Nice. And what is the formula for finding x-intercept is you take the function and you enforce it to be 0. Actually, the thing that we are doing in the chapter 1, when you solving the quadratic equation, was solution of this equation, and basically we are trying to find the x-intercept because this is the function. Look, you enforce it to be 0, and this is the point, important point, suppose the parabola like that, in which the parabola crosses the x-axis. This is the x-intercept, and the y-intercept, no. Y-intercept is when the parabola may be here, cross the y-axis. Okay? So number 1, vertex. Number 2, analyze A. A allow me determine the direction que open the parabola. Si A is positive up, si is negative down. Axial symmetry, very, very important because I take advantage of the symmetry and you obtain more point, more accuracy in the graphic. And number 4, determine super important point is y-intercept and x-intercept. So now, well, the thing that fly in the air, See, I have the equation is given in the original problem, like a vertex form. Oh, it's easy because I am looking who is H and it's K. Now I need to find the relationship, the formulas, to find vertex here when you have the equation in standard. Okay, but this is super easy. Let me explain now. Look, You take, for example, the equation in vertex form. This is f of x or y, either way. Let me try to manipulate a little bit algebra here. Says y is equal, you expand this guy to says x squared minus 2xh plus h squared plus k. And you multiply by a, is distribute a x squared minus 2h a x. Let me copy here to put the x the variable in the last place. 2ha because you are doing the multiplication, this and this, this and this, and this and that, plus a x squared plus k. And we compare now a x squared plus bx plus c, que es the standard, no? And you see, oh wow, a is a. This is expecting, it's logical. However, minus 2ha is b. So I copy separately here, minus 2ha is b. Therefore, h is equal minus b over 2a. Wow, fantastic. I like this formula. It's the most important formula today. So you have the equation is given in standard, but you have no idea who is h and who is k. And h and k are important because of the vertex. In order to find the k, one possibility is when you get numerical h value, you plug it in the original function using the function notation. So this is, suppose that this is 20. You plug in 20 and the y value is k. Okay, another possibility is looking this, that part is equal c. So you copy, c is equal a h squared plus k, no? But I know that h is minus b over 2a, entonces c es equal a paréntesis minus b over 2a square plus k, pero my goal, remember, is k. I need to find k. Entonces es c is equal a negative number square become positive, entonces b square over 4a square. Okay, because 2 squared is 4, a squared is a squared, and at least one a is cancelled out, plus k. Therefore, k alone is equal, is b squared over 4a minus c. Or another more elegant way is put together in one common denominator, okay, 4a, and you have b squared minus 4ac. Can that part look like similar? Let me see, I did well or no? Yeah. Pero this is minus. Sorry, it's minus. I see that something is weird. It's minus, so there is completely opposite signs. This is 4ac, 4ac minus b squared. But don't worry too much. This is k positive. Don't worry too much for that formula because nobody using that formula. What is the most important formula? Well, the most important formula is h. If you want to find k, don't memorize this long formula. No, you plug in h into the function and determine k. Okay? Okay? Let's move on to example. Example, entonces in the example you realize si the parabola que es given in the example is given in standard or is given in the slow intercept. And you apply the corresponding formulas. Because my goal is do the graph of the parabola. Example 1. Okay, f of x, we study, guys, remember quadratic functions. Okay, it's given. Where's the question? Do the graph. Okay, then for doing the graph, I need the paper or Alex or Desmos. Let's do them both. Pero no, okay. We need paper. Okay. Question number 1. The function is given in vertex form or standard.
Vertex.
Vector form. You see clear que A es -2, yes or no? H is 1 and K is 8. Now you compare f of x is equal A paréntesis x minus H square plus K, ¿no? Es obvio que A is -2, H is +1. Be careful with the sign. You see -1, but actually the formula have a minus in the front. So you see plus is because we have double negative. Entonces -1. However, K no, because K have in front positive. Entonces it's the same. K is 8. Now, determine then the vertex is easy. Is 1, A. In the story, it's a vertex. And I plot that. 1, A. Boom. Here. I plot this point. Let me use another color. Boom. This is the vertex. It's the point, 1, A. Okay, number 2 is in what direction open this parabola. I see que A is negative. Therefore, my parabola open down. Y I know que the vertex is 1, A. My parabola open down. When I finish the problem, I see the parabola open down. I don't know exactly where. Open down. Okay, number 3. Number 3 is the axial symmetry. The axial symmetry always is x equals something. X equals h. And who is h? 1. Okay, so from this, I doing my vertical line 90 degree vertical, passing through the vertex. And this split my parabola. So normally the axial symmetry is auxiliary construction and doing in dotted line. And number 4 is the super important point, is the y-intercept and x-intercept. Let's do it one by one. Y-intercept first. Y-intercept, what is the formula? I don't remember. You evaluate the function as 0. Function notation. Entonces, basically is, function evaluated as 0 is -2, 0 minus 1 squared plus 8. Just replace x for 0. Now, 0 minus 2 is -1, but -1 squared is +1. You have -2 plus 8 is 6. Wow, fantastic. And the point is the point 0,6. This is x value that enforcing the situation, and this is the y value. And you plot the second point. It's on the y-axis, 0,6 over there. Boom. Now the x-intercept. Well, x-intercept is the function equal to 0. You take the original function, original. It is -2 parenthesis x minus 1 squared plus 8, and you enforce it to be 0. And you solving this quadratic equation, que is super easy because somebody do the factorization of this. Look, let me show you. -2 x minus 1 squared equal -8. I move 8 to the right hand side. Part negative to both sides. X minus 1 squared equal 4. Oh, easy. Apply square root both sides because I want to eliminate this second power. And this is x minus 1 without square root without second power, it's just x minus 1. So in the right hand side, square root 4 is 2, plus or minus. Don't forget plus or minus. Therefore, x is equal 1 plus or minus 2, no? Negative 1 to the right hand side, like a positive 1. Now we have 1 plus 2, 3, and we have 1 minus 2, negative 1. Actually, the point would be 3, 0, and negative 1, 0. Remember, the condition I enforced at the beginning was y 0. Look at that. Y 0. Therefore, this is the x-intercept. And you plot that. And you plot that. Okay, it's 3, 0 over there, and negative 1, 0 over there. Okay, how many points we have in total? Well, we have 1, 2, 3, 4. And also, I know que the parabola up and down. And I know also que the axial symmetry is the line x equal 1 que split the parabola into equal parts. Therefore, I can infer using my imagination and my common sense. Okay, we have another point here. Okay, by the way, see, this point would be 0, 6. This point would be, this is 1, 2, 2, 6. It's the same distance, because this is the axial symmetry. The distance in this case is 1, 1. See, this is the line x equal 1. This is 2, 2, and the same value of the. I like what happened here. Okay, this is the distance is 2, 1, 2, 1, 2. Okay, ready. So I am ready to do the graph of our beautiful parabola. I try to do my best, however, not always is good. It's important. The parabola never is like that. This is the corner is totally stupid. The parabola is a smooth curve like that. Smooth, smooth. Let me try to do my best. Smooth. I don't think so. Okay, I do it well, but I don't care because in the test I use decimals. In decimals we are doing fantastic. In the rest of the problem we are doing using decimals, and you know very well how you create export the pictures, do the graph in decimal, and you send me back the test day. Any questions so far? Do you understand very well the example 1 or no?
Yes.
Pero no. I want to see in this. Hello, no. I want to see now in this. Same problem in this. Okay, let me try to find this. Well, no Alex anymore. I close the Alex. I open Desmos. Okay, this is my account. I open. Wait. Quadratic, no? Quadratic. I don't save. Okay. Quadratic. I save that. Sí, quadratic function. Suppose it is. There you go. Okay, cool. Okay, I have here the first example. Okay, let me share the screen. Share the screen to the Desmos. Okay, cool. Okay. I have opened already. Yeah, this is the same. Yeah, it's the same. Okay, no problem. Okay, look at that. This is my first problem. Do you see Desmos now? Yes or no?
Yes.
Yes. Okay, let me put it in my graph. Look at my graph. Oh, my graph is, look. My graph is vertex 1,8. Y-intercept 0,6. X-intercept negative 1,0 and 3,0. An extra point using the symmetry is 2,6. Okay, now one more. Well, suppose another typical question, no? Is determine domain and range of that function. Well, it's easy because domain is all real number. Remember. Domain is the set of the x value in which the function is defined. And the function is defined in all real number because we have no restriction. How do you know if we have no restriction? Well, because we have no division, no denominator, no. And also we have no square root, and they are combinations. Therefore, this function is nice, super nice. Therefore, the domain is extending from negative infinity to positive infinity. This is the domain. This is, I don't write this in the board, in the whiteboard, but it's okay. I rewrite after when I come back to this. What about the range? This is important moment. And the range is the y value in which the function is defined. I can see when you're projecting this blue curve onto the y-axis, you see que only the y value que touch or que obtain or we get is less than or equal 8, like that. We have no parabola in 9 and 10 and 11 and 12. No. We have parabola from negative infinity to positive 8, including, of course, positive 8 inside the range. This idea is clear or no? Clear or no?
Yes, it's clear.
It's clear. Entonces, no question in the example number 1? No? No. Cool. Let's move on to example number 2. We have only 3 examples and after application. I try to cover every possibility in the example, no? I try. Okay. Example 2. Example 2 is a little bit different because the function is given knowing vertex form, no. It's given in standard. 3x squared plus 12x plus 5. And we are doing exactly the same. Do the graph, find the vertex, in what direction open, x and z, y and z. At least 5 points is enough. An axial symmetry to determine our parabola. Do the graph. However, remember the first point is the vertex. And the vertex, unfortunately, is not explicit in that way. Okay, no problem. But I can determine. I saw that A is 3, B is 12, and C is 5. Exactly similar the thing we are doing the solution for the quadratic formula, no? But no. In this case, you apply H is minus B over 2A. By the way, guys, this look like, that part look like similar to the first part of the quadratic formula. And this is no coincidence, it's the fact. You divide by 2A. However, you can, if you want, split 2A like that and like that. And this part is H. But this is maybe one, mnemonic device to remember H. And K is a little bit more complicated, but don't worry too much. Now, plugging in, minus, the formula have a minus, B is 12, and 2 times A, que es 2 times 3, que es 6. Entonces, minus 12 divided by 6 es minus 2. I know then que the vertex es lo que era minus 2, something. And K, to find a K, I propose the easy way. You plug it in minus 2 in the original function in order to find the y component associated with the negative 2. And that's it. 3 negative 2 squared plus 12 times negative 2 plus 5. f of negative 2 is, this is negative 2 squared 4, and 4 multiplied by 2 is 12, and 12 multiplied by negative 2 is negative 24, plus 5. Okay, so now, for example, 12 positive minus 24 is negative 12, so 5 is negative 7. It's a K-bar. It's the easy way. No memorize stupid formula because belong to the same curve. So you have the X value, not necessarily remember the formula, the K value. It's a little bit more complicated. Entonces, minus 7. The famous vertex located at the point negative 2, negative 7. Boom. This is my first problem. My second is determine what direction open. To determine what direction open, you analyze only A. A is the responsibility to A is in what direction open. A is 3, que es positive. So, our parabola open up. And by the way, this famous point is the vertex. Negative 2, negative 7. The axial symmetry is H equal, X equal H, sorry. X equal H. And who is H? H is negative 2. That this is the vertical line pass through the vertex, split the parabola in two equal parts. This is the axial symmetry equation. And finally, why not find the intercept. But we discovered one new thing is super important. The formula for finding the y-intercept is the value of the function of 0. And when you evaluate the function of 0 in the standard, it's obvious that 3 times 0 squared plus 12 times 0 plus 5. It's obvious that it's 5. In conclusion, the y-intercept is always z. 0, c. 0, c in general, in our particular example, 0,5. Okay, bueno, entonces some advantage and some disadvantage of the standard and vertex forest. In the standard, you see que C is always y-intercept. This is always y-intercept. Nice, I like that. However, I have no idea for the vertex to say the advantage of the vertex form is, in this case, 3 parentheses x minus, well, actually plus 2 because it's minus the formula for square minus 7, ¿no? Ajá, entonces this equation is equivalent 100% with this equation. They are identical. Either way. Okay, another possibility. Actually, if you want to go from this to this is by completing the square, but no, not necessary. You apply the formulas. The formula is magic. This formula is fantastic. Okay, now one more. Now the x-intercept. The x-intercept, if you have the expression or the function expressing standard, in my opinion, the best way is using the quadratic formula. Okay. I know who is B, who is A, who is Z. Plugging in. A is minus 12 plus or minus square root 12 squared minus 4 multiplication by 3 is A multiplication by 5 is C divided by 2 times 3 is 6. Entonces we focus in the expression inside the radical. That one is 144 12 squared minus 60 is multiplication 4 times 3 is 12 and 5 is 60 and subtracting is 84. Unfortunately, 84 is no perfect square. Okay, you say when this situation happens, you expect irrational solution. Irrational solution, or you leaving like radical, or you express it in decimal approximation, no? Okay, entonces next step is compute the square root 84. Now 84, you put in the calculator and you get, okay, basically is minus 12 plus or minus square root 84 divided by 6. Okay, suppose, let's do it in both ways. Que day one in Alex, in exact answer. Okay, no problem. I take 84. 84 is even, divided by 2 is 42, no? Divided by 2 is 21, and 21 is 3 and 7. And so I can detecting a couple of 2, okay, inside the square root, go outside like 1, 2, and stay inside the radical 3 and 7 get 21. So actually, this is equivalent to say minus 12 plus or minus 2 radical 21 divided by 6. And of course, we can reduce a little bit the lowest term because you divide by 2. So it's minus 6 plus or minus 2 divided by 2 is 1, radical 21 over 3. Oh, nice, elegant. This is the exact answer. Of course, irrational solution, irrational solution. So irrational solution is elegant. However, I don't see graphically because I need to express it in decimal approximation. You take minus 6 plus radical 21 divided by 3 and minus 6 minus radical 21 divided by 3. I put in my calculator. I compute the decimal approximation. And the positive guy is minus 0.47 and the negative part is minus 3.53. Therefore, too long, sorry, but the conclusion is we found 2 x-intercept is at the point minus 0.47, 0 and minus 3.53, 0. So you have plenty points. We have, how many points we have? We have vertex. Cool. We have y-intercept, only 1, and 2 x-intercept. Actually, we have 1, 2, 3, 4. So you need 1/5. You try to find the image of this using the idea for the axial symmetry. Remember, let me review. Vertex of this parabola is located at the point minus 2, minus 7. This parabola open up. This parabola, the axial symmetry, is x equal minus 2. We have 1 y-intercept at the point 0.5. And we have 2 x-intercept at the point minus 0.47, and minus 3.53, Boom. Let's do it. Pero no by hand anymore. I go. 2 decimals. Okay, decimal now for us. Let me share the screen. Okay, over there. Do you see? Do you see or no?
Yes. Yeah.
Okay, example 5. No, this is 2. All right, so 1. This is 2. Yeah, this is 2. Oh, okay, this is 2. But no. 2 is giving. 2 is giving like that. I don't remember. It's the original case giving is 3x squared plus 12x plus 5, no? Yeah. Okay, this is my parabola. Uy, this is my parabola. Look at that. However, okay, no. Okay, now in the whiteboard we get the vertex. Look at that, minus 2, minus 7. In the whiteboard we get the y-intercept is 0.5, and the whiteboard we get the 2 x and z is this number, static. And also, the axial symmetry is the line x equal minus 2. Total we have 1, 2, 3, 4, 5, enough point to do the parabola. However, I want to illustrate that this parabola is equivalent to this parabola. Okay, intentionally I put in different color. This is the vertex form, and this is the standard. So always we can do conversion. And between standard to vertex or vertex to standard, either way, it's easy. Using the formula is fantastic. No problem. Do you see that?
Yes.
Well, to say, where come from this point, professor? Can you never compute that? Negative 4,5. Oh, using the symmetry, right? Because I don't know. What is this distance? This distance, okay, this distance. So the distance from the axis of symmetry to that point is 2, no? Because this line is negative 2. Why x equal negative 2? But the same distance gets 2 to the right and moving to the left. 2. Now this new point is negative 4,5. Is negative 2 minus 2 is negative 4, and the same y value is 5. Boom. Take advantage. This always the symmetry. It's important, the symmetry. We are doing graphic representation. Suppose now, okay, I ask you, what is the domain for this parabola? Please, tell me. To understand, okay, I'm confusing. What is the domain? Area number. Very well. How do you know, miss? You give me your own word. The reason.
It's a parabola.
Uh-huh.
And parabolas, their domain is all real numbers.
That's it. Always the parabola is all real number the domain. However, what about the range? The range, no. The range is in the y value in which the parabola exists. I saw that below -7 we have no parabola. So what is the range of the parabola?
Is it bracket -7 to infinity?
Super. Bracket -7, comma, positive infinity. Let me highlight to see. Oh, this is the range. It's from -7 to positive infinity. Any question? No problema. You feel okay?
Yeah.
Full. One more example. The last one. Theoretical. And now we go directly to applications. In the test, you have 1 or 2 questions. I don't remember very well, but on the review package, you see of the graphic of the parabola and 1 or 2 word problem can involve somehow application for the parabola. Okay, but don't worry, I explain in detail after that. Let's move on again to the whiteboard. We share the screen to the whiteboard. Whiteboard. Okay, do you see whiteboard?
Yes.
Let's do in the number example 3. Example 3. And the example 3 is y equal minus x squared plus 4x minus 5. First question. This equation of the parabola of the quadratic function is expressed in standard or vertex form?
Standard.
Standard.
So you immediately, si you determine que es standard, determine who is ABC. A is -1, B is +4, and C is -5. And remember, guys, step by step. The first thing, because I am doing in the order of importance, The most important point in the parabola is the vertex. And the formula to compute the vertex is h equal minus b over 2. Our specific example, minus b is 4 divided by 2 times negative 1. Or double negative. I like that. Double negative become positive. The answer is positive. 4 divided by 2 is 2. This is h. So we need to find the k. Okay, it's the y value. When you plug it in here, be careful, be careful. It's minus 2 squared plus 4 times 2 minus 5. Be careful because this sign is not the same. Negative 2 squared, que is negative 2 times negative 2. Therefore, it's 4. And negative 2 squared is negative 4. Because this negative behave like a negative 1 outside the game. So actually, k is negative 4 plus 8 minus 5. It's negative 1 because, let me see, it's negative 4 and negative 5 together and negative 9. And negative 9 plus I is negative 1. But the vertex, our famous vertex, is located at the point 2, negative. Cool. Number 2. In what direction open that parabola? In what direction open?
Down.
Down. How do you know it's down?
Because a is negative 1.
Absolutely. Because a is negative 1. When the a is negative, the parabola open down. And this point is the most important point, because the vertex is located at the point 2, negative. Number 3. Number 3 is axial symmetry. Axial symmetry. Always is the same. It's h equals something. Oh, sorry. We forgot that. X equals h. In our specific example, h is 2. So it's a vertical line passing through 2. And number 4 is the famous y-intercept and x-intercept. But it's easy. The y-intercept is evaluate the function as 0 using function notation. It's obvious que 5, it's negative 5, sorry. Because it's c. But the point is a point 0, negative 5. This is my y-intercept. My x-intercept, well, this is more complicated because you need to take the function exactly as given at the beginning and enforce it to be 0 and find the x-intercept. X-intercept is equivalent, guys, to solving the quadratic equation associated with the quadratic functions. Basically, I copy minus x squared plus 4x minus 5 equal to 0. Let's do it. Well, I propose always doing using the quadratic formula, no? But in this case, it's nice. If I don't like personally this negative in the front, so you multiply the entire equation by negative 1, and you convert like that. X squared minus 4x plus 5 equal to 0. I don't know if it's possible by factorization. No, I don't think so. Okay, just in case, to make sure, I recommend 100% using the quadratic equation. Minus b plus or minus square root b squared minus 4ac divided by 2. In this case, can change the sign. A is 1, b is negative 4, and c is 5. I'm plugging in. It's 4 positive, double negative. Negative of the value of the b, negative and the formula b together, both negative together become positive. Square root 16, 4 squared 16, minus 4 multiplication by 1, multiplication by 5, divided by 2 times 1. It's just 2. And we focus it in the expression inside the rack. This is 16, 4 squared, 4 times 4, and this is 20. Wow, look at what happened, it's negative 4. and the square root -4 is imaginary, is 2i, plus and minus. So immediately, can you see this situation? Si you see the expression inside the radical is negative, es the discriminant, o sea, you compute discriminant, b squared minus 4ac. Si this guy is negative, automatically you know que ese complex solution. Ese complex is totally outside the game because we are working in this chapter only using the real number. That in algebra frequently happen. You want to find something. Okay, you are doing your best. You set out the equation, you solve the equation. So you get complex. The interpretation of this is because the thinking you try to find do not exist in the real field. Therefore, we have no, this parabola, guys, have no excellence. No, no excellence. Okay, I respect that. So in this case, we have not too much point. So we need to take advantage of the symmetry. Let me see. We have in my hand vertex. Nice. I like that. We have parabola up and down. Up and down. Axial symmetry is x equal to. We have the y-intercept. Only 1 point. 2 points we have. Wow. At least 3 is enough because the parabola 1, 2, 3. 1, 2, 3. 2 is not good. 2 is not good. So let's using our imagination after that. Okay. Let's switch into Desmos to see the idea. Okay, let me try. Desmos. Share the screen. Share the screen. Desmos. Okay, here you go. Do you see Desmos?
Yes.
We are doing now example 3, no 2. Okay. Then when I do the graphic, I can see clear. Que the vertex is located at the point 2, -1. And we have the y-intercept was 0, -5. And using my common sense and symmetry, we determine another point, not using arithmetic, not using formula, just the symmetry. If this distance is 2, this distance is also 2, and 2 plus 2 is 4, 4, -5. And you see clear like a word now, our parabola never crossed the x-axis. That is the interpretation that the answer is complex because do not exist in the real field. Bueno, maybe see the parabola open up, yes, but the open down never crossed the x-axis. However, yes, crossed the y-axis in -5. This idea is clear or no?
Clear.
Clear. Okay, let's move into the applications. The application is super easy. Okay, you need to. What is important? The application in the quadratic. Well, the application is important because sometimes you have a word problem, and in this word problem, we have. Let me see. Say no. Let's do it. I bring two examples of the application. Here is Mac 11.06. This and this. Application 1, application 2. On. Let's do it one by one. Application 1 first. Okay, what is the idea? The idea is we take advantage optimization. Optimization means find the best option And maybe the best option is the maximum or minimum, depending. And the parabola is a clear example of this. Suppose that we have parabola that open up. This is the minimum. Suppose the parabola that open down. This is the maximum. And depending on the problem, sometimes good the minimum. For example, see you want to analyze a cost of something. If you have money you need to pay, you need to guarantee that our payment is minimum. No? However, si it's a profit, it's a moment that I obtain, I have. So it's good to be maximum. So this is the typical example. Optimization when the quadratic, when the function we are working is quadratic. Okay, so suppose the problem says suppose the manufacturer of the gas clothes dry, it's a equipment like that, prices has found when the price P is the price. In this case, the independent variable X. Normally, we're using in the theoretical part, we're using X and Y, no? Always X is the independent variable and Y is dependent variable. In this case, it's a formula, it's a relationship, but revenue is R. Capital R is revenue, is dependent variable, depending of the price. No? So now the revenue described by parabola. So the revenue R of P is equivalent, no? It's because it's capital R, because it's revenue. So now it's no f of x anymore, theoretical. It's equal minus 4p squared plus 400p. 400, no, 4,000p. Okay, it's important to understand. P is a price. Y price is dollar, no? Okay. And revenue is also money, no? Entonces es dollar. So both, and this not always happen, but in this case happen. Okay, both quantities dollar, no? Okay. However, I can see, what is the question? The question said, what units price should be established? So I need to adjust the price in order to obtain maximum revenue. Okay. Now make sense? Yeah, make sense because it's a parabola. Do you see que es parabola, right? This parabola equation es expresa en estándar o es expresa en vertex form. It's confusing, eh? Estándar o vertex. Remember, in your mind, you suppose that this is f of x, because the function that we are studying is a minus 4x squared plus 4,000x. You see it more clear now? Entonces, ¿es estándar o es vertex form? I'm not sure. Come on, guys, try. There. Estándar is f of x equal ax squared plus bx plus c, no? Something like that. And this look like similar to this or no? Oh, yes. But what's the problem? The problem is que C is missing. So A is minus 4, B is 4,000, and C is 0. So this parabola is missing. It's missing C. Okay. It's no big deal. It's possible. Now, how you optimize this? What's the point? Que minimize or maximize. In this case, maximize. I need maximum. Okay, this parabola open. In what direction open this parabola? Open down or open up? Hey, what happened? You are there or no? Come on, guys, participation. In what direction? Remember, participation is important. All right. Professor, we can only see decimals. Oh, I forgot to share the screen. Ah. Okay, no, don't worry. My screen frozen. Oh. Okay, don't worry. Let's do it again. Let me share the screen. I forgot something. No, this is the Microsoft Whiteboard. Do you see now or no?
Yes, we can see it now.
So forget about this. You see what happened with the student? You don't say anything. Are you warning me? So you don't share the screen because sometimes I focus in the mathematical part. I forgot to do this. Okay. Do you see the word problem? The word problem talking about the manufacturer of gas clothed dry has found the connection, the formula in between revenue and price of this equipment, of course, is R as a function of P is equal minus 4P squared plus 4,000P. So when you see exponent to this sound like a quadratic equation. So the thing I tried to explain was que this is expressed in standard. No, let me compare. You see, you are familiar with the x, ax squared plus bx plus c. No, it's obvious in this problem a is -4 and b is 4,000 and c is missing. It's 0 because we have nothing here. No, just the number, right? C is not depending on variable. In this case, my independent variable is P. Okay, P is the price. Price of what? Of these appliances. And to say I need to investigate what is the correct, the optimum price. Okay, you adjust, you know, okay, our revenue obey to this equation. Entonces, esa parábola, you identify who is B, who is A, who is C, and this parabola open, in what direction open this parabola?
Down.
Down. See, this parabola open down makes sense to discover what is the maximum. And the maximum value or the minimum, depending the problem, occur in the vertex. The conclusion, I need to find the vertex point, and that's it. Super easy. And the formula is H is equal minus B over 2A. This is the fantastic formula in the application. Okay, entonces minus B is 4,000 divided by 2 times -4, no? Double negative become positive, makes sense because H is a price in dollar and negative dollar is no sense, it's a price you need to pay, but no, it's okay. Therefore, you compute that, you divide 4,000 divided by 8, que es 500. Sometimes in the application asks you about the optimum, pero sometimes it's important to discover the independent variable value. Remember, the vertices have h, k. H represents the price optimum is $500. This is the final answer in the story. And in some problem, ask you about one you adjust this price. What is the revenue? you get in the company, manufacturing company. Bueno, it's easy. Yeah, you plug it in, pero no. In this case, this is the final answer. Don't. However, if you want to find revenue, you plug it in the function of $500 is -4 times 500 squared of 4,000 multiplication by 500. Okay, one is negative, another is positive. Okay, I put in the calculator either way. And the revenue, que is not the question that they want in this problem, but by curiosity, I did that, is 1 million. Okay? Is it clear or confusing?
It's clear.
Here.
Let's do another application que is similar. Look. This application is about marginal cost in dollar of the manufacturing of the cell phones in thousand is given by this. So this is a formula que give me cost, no profit. It's just money, pero es the money I need to pay. I realize that I am the manufacturer, for example. I need to pay to build any smartphone. This equation. Entonces, who is X? This again is 4,000. X is the number of cell phones, pero no one, sino in thousand. Si X is 1, is 1,000. Si X is 2, is 2,000. How many cell phones should be manufactured to minimize the marginal cost? And you have two questions. You need to find, I know that the optimum occur in the vertex. And this parabola, in what direction open? Open up or open down?
Up.
Up. Si open up, to say this vertex is give me a minimum. It's exactly what we need in the problem. How many cell phones should be manufactured to minimize the marginal cost? So I need to investigate what is the minimum. Can you plug in here and give me the minimum cost? Okay. Again, conceptually, I know that this situation happens in the vertex. I know very well that the formula for the vertex is minus b over 2. But in our problem, AFI, b is negative 200 and c is 1,000. Fortunately, in the formula of the H do not participate in C, only A and B. Cool. This is minus. Entonces, substitution is minus 200 divided by 2 times 5. Double minus become positive. So actually, we have 200 divided by 10. 20. H is 20. 20 what? What is that? Dollar? Is it 20? Is it 20 alone? Is it 20,000? Now what is the unit? What interpretation? What is H? Remember, in any quadratic function, we have two components. We have two variables. Independent variable, in this case is X, is the cell phone in thousand, and cost, que is money. I suppose that this is money, and this is no money, it's cell phone. In thousand. Entonces, basically, the optimum value is 20,000 cell phone. Entonces, when you try to manufacturing 20,000 cell phone, we need to invest this money. Entonces, this money is a cost, evaluate in 20, not in 20,000, because the formula implicit suppose que es in 1,000. So you multiply 5, 20 squared minus 200 times 20 plus 4,000. Bam, 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 bam. Calculator, calculator, calculator. And the answer is $2,000. Yeah, because it's minor here. And it's no big deal. It's not too much money. Okay, so it's, I don't know if it's real or not, this number, but I take in the book. Okay, therefore, this is the minimum cost. Do you understand the idea or no? Confusing or clear?
It's clear.
Clear. Okay, now we go directly in the time that we have to super important topic inside the chapter 2. It's about introduction to whatever polynomial functions. And of course, the quadratic we studied before, example of the polynomial. Remember the definition of polynomial. The definition of polynomial is a collection of monomial. Collecting different monomial. 1, 2, bueno, si es 2 es binomial, si es 3 es trinomial, no? Si es 4 es polynomial. In general, poly, when you talk about poly, it's because we have 4 or more than 4. But it's a monomial, no? So what is the most important thing in the monomial? And the monomial is, suppose you have monomial is only one. You have one coefficient, 2, for example, and this coefficient must be real number. What mean to be real number? Well, it's 2, it's 2/3, it's radical 2, irrational, rational, the decimal. Now, this is the coefficient and the monomial coefficient. Entonces, suppose to simplify the thing, we have variable, suppose x squared and y4. Suppose 2 variables. Normally, the polynomial that we study in this chapter is not using only one variable, but I want to illustrate that it's possible 2 variables. Now, this is coefficient, but it's super important detail to characterize like a monomial, that this exponent would be whole numbers. Whole number means 0, 1, 2, 3, bam, bam, bam. So positive integer. No negative 1, no fraction. It's a whole number. And by the way, the degree is 2 plus 4 is 6. It's the sum of this. In this case, because you have 2 variables, but another more interesting problem. For example, suppose one polynomial 4x to the 5th power plus 5x to the 4th power plus 2x to the 3rd power plus x to the 2nd power plus 6x plus 8. It's a typical polynomial function. In this case, using one variable, it's exactly the thing we study. One variable x, one independent variable, no 2. Entonces es obvio que es the collection different monomial, 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 and monomial. And the coefficient of this monomial is 4. And the degree of this monomial is 5. And the coefficient of this monomial is 5, and the degree is 4. Wow, by coincidence, I copied switching. Coefficient is 2, degree is 3. Coefficient is 1, you see invisible 1 here? And degree 2. 6x, coefficient is 6, degree is 1, because they're linear. And the last one, coefficient is 10, and degree is 0. because we suppose que es x to the 0 y x to the 0 es 1. So when you see one number alone without variable, it's because degree is 0. Cool? However, what is the degree of the entire polynomial? Oh, it's the highest one. It's 5. Okay? Okay? For example, so you have a function like that. I put it weird. Suppose 30 x to the minus 2 plus 50 x to the 3 over 4. This is no polynomial because the characterization definition of the polynomial is the exponent are whole numbers. No fraction, no negative number, 0x possible, like that. 1, 2, 3, 4, 5, 6, 7, whatever. No polynomial. Yes, it is polynomial. Entonces, clear definition. To start, no? Definition.
Yes.
Yes.
Okay, beautiful. Now, it's important to say something. The graph that we are doing so far, the polynomial function are nice. What mean to be nice? It's nice because we have no, it's continuous. So the graph of polynomial function is always continuous. What being continuous? I promise in calculus 1, que es math 2311, we study in detail the idea, but to get an intuitive idea, what is continuous is a curve that we can draw without listing the pencil from the paper. For example, so you are doing this, no continue, discontinue. Okay, so you, for example, you are doing this, we have a hole, no, discontinue. So I guarantee 100% that the graph of the polynomial always is continuous. So no gap, no jump, discontinue, nice, beautiful. And also, another important property, number 2, is smooth. What means smooth? This is smooth also. But for example, not necessary to be continuous to be smooth. Smooth is a little bit more, important. No, this is function is supposed this function, boom, is continuous. Yes. However, not smooth because we have a corner here. A corner, a cups. This is a typical name, cups. Corner, points. This is a sharper point, This is not smooth. Smooth to be like that. Ooh, smooth. Look, like, remember, when you are doing the graph of the parabola, so you are doing like that, it's wrong. Because we have here a corner. No corner, it's smooth like that. And the graph of the any polynomial is smooth like that, okay? Clear? That's a bit, be careful. Smooth and continuous. However, let me study now in behavior. In behavior of the behavior, B. In behavior of polynomial functions. What is that by definition? In behavior is when you analyze the function f of x, que I suppose que es polynomial, pero you analyze when the x approaches to infinity positive or infinity negative. in both directions. Suppose we have here all real number line. Okay, all real number line. Let me copy two real number line. 2, 1 and 2. Okay, entonces I want to anticipate. Okay, this is my all real number line. This is infinity positive. This is infinity negative. This is infinity positive. This is infinity negative. Of course, 0 in the middle. I omit the y-axis, pero you know que es in that direction. Suppose one curve like that. Suppose que the function is even. What means to be even? Even is a function that when you are doing reflection, remember this kind of reflection. So you have a function, or the original function, and you artificially, to investigate that, you make a reflection. You replace x for negative x, and nothing happens. Stay the same. When this situation happens, this function is even, and this is completed symmetric with respect to the x-axis. So now, suppose que es something like that. Okay, just in case you want to see the y-axis, let's do it. Y-axis, 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 90 degrees. There you go. This is the typical even function. It's obvious that when you are doing reflection, nothing happens because the reflection is above or across x. But this is the even function. And what about odd function? Odd function is something like that. Odd function. Odd function is the function that when you produce the same reflection, is x, something happens. No stay the same. It's minus f and x. In other words, when you have the function and you are doing reflection about the y-axis, it's equivalent to do reflection about the x-axis. Okay, typical function that satisfies this idea is something like that. But let's move on to the idea for the aim behavior. That's the thing I try to discuss now. Aim behavior is when the x approaches to infinity, positive. It's in this direction. I can see clear, like a water. Ky approaches to infinity positive, increasing. And here, when the x approaches to the negative infinity, I see ky approaches to the positive infinity because it's going up. Okay, so now one terminology that normally is using is this is right up aim behavior, and this is left up. But not always happen that. That happens when it's even and the coefficient in front the function is positive. The coefficient is positive. Si the coefficient is negative, bueno, it's okay. No problema. It's negative. Let me use another color, maybe green, which is negative. The even function look like that. Then the aim behavior is right down and left down. Actually, we have 4 possibilities, guys. The aim behavior. Similar situation happen in the odd function. In the odd function, when the coefficient c is plus, is something like that. Is right up and right up and left down. Down. However, si the coefficient is negative, the behavior was different. It's like that. So it's right down. So it's a compound word. It contains two pieces, right down and left. So this is a little bit confusing. However, let's go to the example and you see super clear. Super clear. Find the end behavior. It's super important to find the end behavior when you're doing the graph of the polynomial, no? Suppose example one. Suppose f of x is equal minus 4 x to the 5th power plus 5 x to the 4th power plus 2x. This is a polynomial is given. And so now the questions say, find the end behavior expression. Let me call here end behavior expression. This is acronym to say end behavior expression. Okay, EBA is okay. You're not like wow. What is the dominant? What is the dominant? This is important word. What is the dominant? When the remember the end behavior is when the x approaches to positive infinity or the x approaches to negative infinity. So the interpretation of infinity is a huge number, million, trillion. And when you plug in a huge number, the dominant term is the term that contains the higher exponent, this one. Because it's obvious that this is completely neglectable. Not important. Because this is increasing faster, no? Entonces, minus 4 x to the 5th power. This is the end behavior expression. But I want to investigate the potential idea. Look, this is my axis. Yeah, I know that the function is odd. How do you know it's odd? Because the point 5. Now it's odd. And the coefficient is negative. So now my graph look like I don't know, something like that. Con. So I don't know exactly what's going on in the middle. This is not important for me now. The most important for me now is to study end behavior. And end behavior is the behavior of this polynomial function when the x approaches to positive infinity in that direction, or when approaching to negative infinity in that direction. This is obvious. It's right down and it's obvious it's left up. Make sense? Make sense? Entonces, yes. When I finish, I suppose that my graph look like that. Boom. Boom. I don't know exactly what happened in the middle. It's not important for me now. The important is that part and that part. This is the end behavior. Okay. One more example. Complicated, a little bit confusing, tricky. Example 2. End behavior. Suppose the function I want to change the name, g of x, is equal 1 over 4, third fraction. Coefficient c is positive. Opponent no, but coefficient c yes. 2x minus 3 cubic and x plus 4 to the second power. And it's a polynomial, professor? Yeah, it's a polynomial, but the problem is that somebody, not me, do the factorization to say you not write in that way, it's more clear, because somebody, not me, expand. All right, in descending order of the degree, 5, 4, 1, because 2, 3, 2, and 0, and missing. Okay, no problem. However, this is factorization. Somebody do the factorization. Okay, it's a classical operation in algebra, factorization. Okay, somebody. However, I need to study n behavior. N behavior is when the x is a huge number positive or a huge number negative. Okay, so now the way to analyze this is you delete mentally in your mind this guy and this guy. Why? Because this is 1 million. 1 million plus 4, 4 is nothing. And 2 times 1 million is 2 million, minus 3 is nothing. This should neglect that. Entonces, the n behavior expression for the function g is 1 over 4, the coefficients stay, x, and this is 2x cubic and x squared. Do you follow me? Do you understand what is the reason I delete 3 and 4?
No, I didn't understand.
Aha. Suppose que you plug in. Suppose 1 over 4 multiplication by infinity. Of course. Let me explain something that you see in calculus. Infinity is no number. Infinity is a symbol. Indicate it's a huge number, positive or negative. So when you are doing the second parenthesis, get 2 times infinity minus 3, and this is infinity plus 4, you see that infinity, for example, you can interpret it like 1 million. And 1 million times 2 is 2 million. And 2 million minus 3, you say that this 3 is totally negligible in front of 2 million. Do you see or no?
Yeah, I see.
Aha. So you remove the number and to investigate the n behavior expression. Okay, now I finished. No, almost. So now we have 1 over 4. Let me continue manipulate this part. X, this is 8x cubic, because 2 to the cubic power is 8, and x to the cubic power is x to the cubic power times x squared. And 8 divided by 4 is 2. X to the, how many x? 6, 7. It's 7. It's 6. No, it's 5. 2 plus 3 is 5, sorry. Plus 1 is 6. Wow. This is my n behavior expression associated with this polynomial. Aha, when the polynomial is expanding, it's too easy. Because you take the expression, the monomial can have the higher degree, but in this case, no, put intentionally to confuse you factorization, right? But the most important is not that. The most important is try to do approximately the graph of the hour polynomial. This n behavior is even function. Is even function. How do you know it's even function? Because the exponent is even. As yes, even function look like that. The n behavior. And wait, and also the coefficient is positive. So now the n behavior look like that. Yeah, I don't know exactly what happened in the middle, but the n behavior, one more time, I explain, is when the x approaches to infinity, y approaches to infinity positive. And when the x approaches to negative infinity in that direction, y approaches to the positive infinity in that direction. Go up is right up and left up. Do you see or no?
Yes.
Cool. This is super important, and we checking. Of course, we are doing decimals. In decimals you can see, but this is part of the game. Determine the aim here. Let's do it in the time that we have. Some example. No big deal today. Next time, yes. About graphic of the polynomial, no? And let's check in decimals. Oh no, not yet. Let's one more concept. I need to discuss with you. It's about identify. When I'm behavior for a moment, it's okay. Now, identify zeros and multiplicity of polynomial function. What means zeros in the language of the polynomial? Zero of the polynomial are zero is equivalent. Zero is zeros is equivalent to the x-intercept. That's the point in which the polynomial graph crossed the x-axis. So let me investigate one example, no, of this, and also, by the way, I take advantage the end behavior also, no, because I want to. Suppose the function like that, f of x equal x cubic plus x squared minus 9x minus 9. This is given. This polynomial. Question number 1. What is the degree of this polynomial?
3.
3. It's 3 gets the higher, small. What is the end behavior expression? The f of x. What is the dominant? What is the term increasing faster? Remember, end behavior means x approaches to positive infinity, x approaches to negative infinity. This is the idea behind this word, in behavior. So now, when this is a huge number, what is the dominant? What is the part in the polynomial that control the increasing faster? 9 minus 9. No, this is constant. Stay the same. This is linear. No, this is quadratic. No, this is cubic. Too fast. But the higher exponent is always the end behavior. You take in the polynomial, no? In another function is different. In the polynomial, end behavior expression is x cubic. The reason is this is the most important part in this situation. The control when the x is huge number positive or negative. Make sense?
Yes.
Therefore, I can imagine the shape of this graph. The shape of this graph and the end behavior is, this is the odd function because the exponent is 3, it's odd number, x odd exponent, and the coefficient is positive, guess what? Therefore, in my imagination, this is the graph. This is the end behavior. End behavior is right up and left down. And the middle, no idea what happened here. But the end behavior, I am sure gets like that. Let's move on to the zero. Zero is the axial set. Find the axial set. You know very, very well the formula. The formula is you take the function and enforce it to be zero. In our specific example, x cubed plus x squared minus 9x minus 9 equal to 0. Wow. And we have, in that moment, one polynomial equation similar to the thing we are doing in the chapter 1. And so far, I promise the next time we study another more sophisticated technique. So far, we are doing by factorization. And factorization is super easy in the case because this polynomial contains 1, 2, 3, and 4. And you apply factorization by grouping. Remember the couple green, the couple red, and the couple green. The GCF and this couple red is x squared. X plus 1 inside the parentheses. The GCF and the couple green is negative 9. That's x plus 1. You follow me?
Yes.
Now x plus 1, I can see again que es a common factor. I factor out. X plus 1, x squared minus 9. I finish now. No, because I can continue factorization. I can see clear that x squared minus 9 is a difference of a square. One possibility is continue factorization using the formula difference of a square. The formula you very well know is a squared minus b squared is equal to a plus b, a minus b. It's a one option. So xx is square root x squared and square root 9 is 3. So minus equal to 0. Therefore, you apply one more time now here the zero factor property. Okay, when you have three factors equal to 0 is because maybe the first factor is 0, or the second factor is 0, or the third factor is 0. And you solve it. It's a negative 1. This is negative 3. And this is positive 3. Entonces, to have some idea how it look like our polynomial. Okay, I have here the end behavior part. Let me complement that a little bit, not too sophisticated, but a little bit more. This is x-axis, this is y-axis. I know very well the behavior, end behavior look like that. Hong Kong. However, I determined 3 points in which the polynomial crosses the x-axis is negative 1, here, negative 1, of course, comma 0, because the y is 0, negative 3, negative 2, negative 3, comma 0, and positive 3. No? 1, 2. Now, this point was negative 1, 0, negative 3, 0, and positive 3, 0. Okay, I put that. Now, roughly sketch by hand. My graph look like that. And behavior in that direction. Cross it here. Cross it here. Cross it here. And continue. Cool? Well, approximately, you know, it's a roughly sketch. But see, you want to complementary more, a little bit more clear. Maybe you find, why not, find the y-intercept. And what is the formula for finding the y-intercept? Evaluate the function is 0, you know very well. When you evaluate 0, replace x for 0, the answer is negative 9. Wow, so this is not good. This graph is not good. I don't like this graphic. I don't like this graphic. Because I found algebraically here, okay, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, and negative 9. This point is a point 0, negative 9 is the graph. Entonces now complemented more, a little bit much better is this. I don't know exactly what increasing here, return. It's going down to the negative 9, and now we continue here, passing through 3, and continue forever. Okay, so you see in behavior, you see zeros, que es the terminology, the word applied for the excellent set, and we see y in a set. I suppose que es enough. What about multiplicity? Multiplicity and the relationship. Let me explain this. So multiplicity is, okay, let me explain multiplicity. After I put another example, but let me explain multiplicity, and that's it. It's too much for today. Suppose that when you are doing the factorization, let's see another example. Example 2, quickly, to understand multiplicity. 0 and multiplicity. Example 2. In example 2, you have the function f of x equal x to the 4th power minus 4x to the 2nd power. Okay. In behavior expression of f of x is obvious x to the 4th power. And x to the 4th power is even exponent to lie like that. And coefficient positive. The coefficient is negative, it's down, pero no. And you factorization this, suppose que you try to investigate the zeros of the polynomial. Okay, no problem. The greater common factor is x squared minus 4. And you factorization, this is 0, sorry, x squared, and you break it down again, similar we did before with the difference of square, get to do plus or minus. And you get 3, 0, only 3. Because you apply one more time the zero factor property, does x squared is equal to 0, it's equivalent to say x equals 0 because the square root 0 is 0, and 0 have no sign. And x plus 2 equals 0, x equal minus 2, and x minus 2 equals 0, x positive 2. Now, I plot that point. The point are 0, 0, minus 2, 0, and 2 positive 0. So 0, 0 is the origin. This is 2, 0. This is 0, and this is minus 2. Okay. And what about multiplicity? Multiplicity. What is important of the multiplicity? To understand multiplicity. Multiplicity is singular. Multiplicity. Okay, actually, the degree of this polynomial, okay, I forgot to explain that part, is 4. And when you try to solving the polynomial equation, obviously we have 4 solutions. It's exactly the degree. We studied this in the chapter 1. But what is the 4 solution? Because I see only 3, 0, negative 2, and 2. The problem is the multiplicity is n 0 is 2. But actually, multiplicity 2, multiplicity 1, and multiplicity 1. Actually, see, you write solution set of this polynomial is 0, 0. Because this 0 is repetition, is repeated. But of course, you consider one time. But it's important to understand the multiplicity. And minus 2 and 2. Actually, we have 4 zeros, but 0 is special because 0 have multiplicity. And when you have multiplicity 2, next time I explain again that part. the graph touches the x-axis. However, when the multiplicity is odd number, 1, 3, cross the x. Okay, this is important property. Okay, look. This is the end behavior. This is the end behavior. This is the end behavior. It's going up here. Cross, touch, and cross. Okay, repetition. Next time I explain detail. When the multiplicity is even number, the graph touch the x-axis. When the multiplicity is odd number, the graph cross the x-axis. Guys, too much for one day. Okay? Today was excellent because I suppose that nobody touched the stop recording point. Yeah, I suppose that the video is recording completely, right? Now I stop recording. Yeah, I will